Okay, okay, now I am here. So my name is Emilio Mariscal. I am a software engineering manager at HOT, the Humanitarian OpenStreetMap Team. I am also a volunteer firefighter in Argentina. And this talk was originally in Spanish, but now I am doing it in English. So I'm making a good effort to do this. Okay, now, yes, this guy. So first, can I help you with that mapping, it says. So let's consider what we mean, first of all, by artificial intelligence. In a general sense, AI, artificial intelligence, is the intelligence exhibited by machines, especially computers. While data processing had existed from a long time, what we call AI is a set of technologies that allow computers to, in a way, understand and participate in the world. Hope not this guy. So recently we have seen an explosion in the news about AI. For example, the classic news stories that tell us which is the best yerba mate in Argentina. So it's the AI. It says which is the best Uruguayan yerba according to the artificial intelligence, or the best Marvel characters, or the best season of The Simpsons, the best place to live in Colombia, or a list of simple phrases to express love for your children. There are people that are interested into that, as you see at the bottom here. Frases sencillas para expresar tu amor por tus hijos, según la inteligencia artificial. Always according to AI. So what we see is the product of the so-called generative models, which can create text and images that often appear to have been created by humans. Often, sometimes not so much. So what do we want from AI? How we can create an AI that serves our real-world problems? How we can create an AI for a better world? And we see here this famous meme about it. So, how does artificial intelligence work? What is it made of? And can we create our own AI? How AI works? Okay, this is how AI works in a very small graph. So we have this thing that we call the model, and we have data that we input to our model, and then the model will output the results. This is basically what we do. We write something to ChatGPT. There is a model that will process that text and will output a different text. That is all. That's all. So the model is a kind of program that is trained to recognize patterns, right? So we have a lot of data that we use for training our model. So we feed our model with data that we will use then. So for example, if we fill our model with a lot of images of cats and other images that are not cats, and we tell the model, this is a cat and this is not, this is a cat and this is not, the model will be able then to say, this is a cat. We will be able to provide a new image that is new to the model, and the model will be able to tell us, yes, this is a cat and this is not, right? So, but also what can happen is that we have bias in our model. So if we, for example, we only show the model orange cats, it will be harder for the model to recognize black cats or gray cats, of course. So our model will be biased. So this means that we include also our prejudice about how something should look or how to be classified. A well-known example of this is image generation model that reproduces stereotypes. So every time people was asking this model, and this is a real example, of course, for a Mexican guy or people from Mexico even, this Mexican guy was always with a big hat and the el bigote, the mustache. So yeah, so this is an example. Another example was some certain models that were unable to recognize, to do facial recognition of people with different colors of, different tones and colors of skins. So well, that was a really big problem, and even also models that identified people as potential criminals based on the place of residence. So depending on where they live, the model will be more biased into identify these people as criminals. So you see how this can be more and more serious. So when we talk about maps, we also need to consider difference and diversity. For example, a residential neighborhood, typical to the suburbs of some areas, with its gray roofed houses, as you see here. Now where is the? It's here. Here, and the paved roads and these green gardens. This is a typical movie neighborhood. Is different from other places of the world where maybe there is a more like a desert landscape full of yellowish sand, and maybe also other structures around the houses, or a village with some square and rectangular houses, but other circular houses. So it's very different. Even we have here different shapes, but also different colors for the roofs of the houses. And even some of the houses were sadly burned, as you see here at the bottom. Or a very dense populated settlement with constructions of various materials, one on top of the other, like the vacheadas here in Brazil. These are very common in our Latin America and all of the world. So this is another challenge to identify this kind of buildings. So returning to the models, in most cases there are black boxes. We can see how they work, what they are inside there. We can use them. When we heard about, there is an open model. Open AI is not even open, but there are other models that you can download and use it. For example, there is a model Llama from Meta that you can actually download the model and use it. I have a couple of models running on my computer that I can use without internet, and I can make use of them. But I can see how they are made, what data was used for train them. That is not possible to know that. So we don't have control over these models. So the name is open and are open for use, but not really open. We can improve them. We can adapt these models to our needs. The alternative is to create our own AI models by using our data and to create our models. So we will have more control over our results. Ours will be for everyone and for all the uses that we need. In our case, what interests us is the creation of maps. So creating an AI model might sound complicated for some people, and sometimes it really is. But at HOT, we are working on a tool for making this easier. So we are developing this tool that the name is fAIr, HOT fAIr. And this tool allows us to create models, open models, in a relatively simple way through a website and without needing expensive infrastructure. The ingredients that we will need are aerial images, which can be our own images created, for example, with these little things that are a cheap drone that we can use to obtain aerial imagery with a license and usage rights that are compatible with the things that we want to do, because sometimes that is not the case if we obtain images from satellite providers, for example. And human mapping. So we will need we will need the polygons of the that will say to the model, hey, this is a building and this is not. This area that you see here that is covered in white is a building, but the other part of the image is not, is sand. So we need these two ingredients, aerial imagery and human mapping or geospatial data. It could be obtained in other way, but mostly it's human mapping. With these two ingredients, we can create an open model. And this aerial imagery and the human mapping that we see here as ingredients, in our case in HOT, we have several tools that we use to enable volunteers around the world to produce that data that is available then for the same people, for the communities to also play and experiment with these kind of tools to create models. So the model will learn from these examples, which we call the training data set, and we'll then be able to distinguish which parts of an aerial image belongs to a building and which do not. What is interesting is that these examples will be based on the area which we are interested in to work, with its own characteristics, like the texture of the building, of the roof, and also the color of the roof. But for the map to be truly complete, we will also need humans to review the results of the model. And because we are a humanitarian OpenStreetMap team, it's a humanitarian organization, so we want to include people into the process. So what we do is to enable a feedback mechanism, so people can also review the results and provide feedback about each of the features that were produced by the AI model, and until when the model did it right and when it not. In addition to this, people also contribute with local information that is not possible to see in an aerial image. So, for example, such as the name of the place or the type of services that the buildings provide. And that also could be used sometimes to not use certain geometries to train the model, because maybe we know that some things are clearly not a building, but are other things. And for that, we use a computer and a phone, so people can create all the geospatial data that is needed for training the model with very accessible and simple tools. As you see, it's very different from what we see before, where with other models where we don't know where the data is coming from. In this case, we know exactly how to reproduce the same process and how to produce the data that we will need. So I will show you now some screenshots of this tool, of fAIr. fAIr is in production. You can actually go to fAIr.hotosm.org, and you will be able to play with it. In that URL, you will find the old version or the current version. That is not this one that I will show you now. That is the one that we are about to launch next year. That is with a new, improved design, and also other things. So basically, you go to the website, to fAIr. It's not that beautiful right now, I warn you, but it's working. And here we see some models. We click on to create model, and then we start this process of creating our own model. We put just a name, a description, and we can choose, here it says base model. We can choose different base models. There are YOLO or RAMP. There are models that are more adapted to this kind of work that we want to do, that is detecting buildings in this case. fAIr is not exactly just for detecting buildings. The buildings is more like the first step, because there is a lot of more data to work with that with other things like rivers or roads or other things that we are interested in to detect. So we are starting with buildings, and we will see that you have several base models available. So you start with that. So the base models are models that are specialized in certain tasks, like detecting objects or detecting certain features that we want from the image. And then we create a training data set. So this is where we select these two ingredients that are the geospatial data that can be from OSM or can be your own geospatial data that you have in a GeoJSON file or any other kind of format. You then select the imagery, so you can put a TMS link and use that for training the model. As you see here, usually it's data from Open Aerial Map because it's easy to publish there and use it. And even more if you use one of these little things, the drones. And then we select area in where we have both things. So maybe what we usually do is we work with, we capture imagery with this. This is part of the previous talk that I did. For some of you will find this familiar. We capture imagery with these things. So we have high quality imagery. We do, we run a small project of mapping of with volunteers, so of collaborative mapping. So we have a tool so people can map certain areas from their houses. But instead of doing this for the entire imagery, we can do this for a small part. So maybe 30% of the town will be mapped manually. With that data, we will build this model for mapping the rest of the other 70% of the city or of the area that we want to map, but using AI as an assistant. Here we see some experimentation where we see all the buildings that were detected by the AI tool. And we have also, while we are, sorry, this is the data that we will be used for training. These are the geometries and the imagery that we will use for training. And then we have the option to tune our model with some options, changing the configuration. For example, epochs, batch size, those are like classic variables that we can change when we train models. But we also are building this in a way that we can have different different types of users. So maybe you are a basic or intermediate or advanced user, and you will see different options. So it's not too complicated for some people to use, and they can play with it, and they can experiment and can learn. Sometimes you will start using the basic, and maybe the results will be not so great, but as you can progress with your learning, you will be able to experiment with the more advanced and complex configurations. So basically, it's a UI for training models, AI models. We are using TensorFlow, by the way, for doing the actual training of models. And you see here the model summary with all the things that you selected, and then this will be trained in our own infrastructure, so you don't have to use your own computer or infrastructure for doing it. Here we see the results of the training. These also are usual indicators that you will find when you do these kind of things. Like two very important things are accuracy, validation and training accuracy, that will be telling you if the model is working or not. Maybe things that can happen is that maybe the data that you have are not that good. There are buildings that are not mapped in a good way. The geometry is not correct. And the geometry, maybe the box that was mapped over the building is also including other parts of the area, like grass or things that are not actually the building, and this is like introducing noise into our model training. Or other things that can happen is that there are buildings that are not mapped. So you have aerial imagery, and you are using this area with some of the buildings mapped with the geometry over the imagery, and other areas are not. There are not geometries. So the model thinks that you want to say that some things are not buildings because there is nothing to say to the model. Here, this is a building here. So that also may introduce noise. So when you look these results, you maybe found that you have to go back and improve your data, like review if the aerial imagery and the geometries that you have are good for what you need. And we see here is what you can find right now on the website. If you run the whole process and then you go to start mapping, you will see something like this. This is our real results. And you see here the feedback mechanism that I was talking about before, where you can select one of the predicted buildings, and provide feedback to the model and to the developers, to the tool. And you see here there are some examples like here, for example, these are two buildings detected as a single building, for example. This is a mistake. Or maybe there are small features that are detected also as buildings should be not. There are some configurations parameters that also you can change to avoid some of these things. Like, for example, you can say what I am looking for are objects that are bigger than certain surface, like 1 square kilometer or less, but you understand. So you can also do that, and also change how tolerant you will be for building detection. And also, if you see that the corners are square, that is also a feature that this tool have, to square all the corners or to not. And you can use this data not only for obtaining the final footprints of every building, but also it can be used for look for buildings. So to see if there are buildings in an area or not, or to count them. So it's not really, for example, for me as an emergency responder, it's not that important to know exactly where the building is, but to know that there is a building. So if I took all the centroids of all these polygons and use that, for me, it will be enough, really. So, yeah.
Is there any parameter like you have to play with, like confidence level, to detect more or less when you are using the AI detection?
Yes. Salim is talking about this, if there is a confidence parameter to detect more or less. Yes, there is a confidence. You don't see here, but there is like a sidebar there with several options that currently is kind of confusing, some of the terminology that the developers are using, but we hope that with the new UI will be more clear. And some of the challenges, so we finish this, is about multiple buildings detected as one big building because they are sharing rooftops. We see these 4 squares, and actually the tool detects that as a single building, but we used the aerial imagery from these things to have a 3D view and actually look in 3D, and that is how we know that was not a single building but 4 different buildings. So that is how we also rely on other tools and into the community to improve our data. But yes, this is a challenge. Also, lack of data to expand detection to other humanitarian features. So, for example, destroyed buildings, that will be amazing to have the possibility of not only detect buildings, but also buildings that are destroyed. Or other kind of things like burned areas or burned buildings. So we are exploring new models like IBM Foundation model for Earth observation. We are researching potential of rooftop material detection, also detect what is the material of the roof. That will be useful for evaluating greenhouses effect. Also, we are refactoring the user experience. It's like what I just showed to you for the version 2 of fAIr at the end of this year. And we are conducting more field user acceptance testing in 2025. So next year, we'll be working a lot with communities in different parts of the world, what is present in Asia, Africa, and Latin America and Caribbean. That is what we call the priority countries. Yeah, you see here where this tool fits on our solution that we call the end-to-end open tech mapping solution that goes from flying drones to having a map that you can actually use. That's all, and I invite you also to this Sunday. I will be doing an end-to-end workshop, so I will be showing most of these technologies, and we will be talking about fAIr also. Thank you so much.